This video is about the MALDI TOF analyzer, how it works, and how to use it. Specifically, how we can use it to identify unknown organisms. First on the list of things to learn about is the inoculation plate. This piece is small and has many circular targets arranged into lines across its face. Each target is a potential spot to inoculate an unknown organism, as will be demonstrated later in this video. It is possible to use multiple spots with the same organism to increase the chances of success in identification, but single spots will be used in this demonstration. Here we can watch as I inoculate an unknown bacteria I grew from swabbing my hand. Here we can watch as I apply what is called the matrix, a liquid kept in a small vial. We will talk about this more later in this video. Related to the target is the matrix used with it. Once a colony is placed onto the target, you have a short time, about 20 minutes, to apply the matrix to the target before the organism dries out. The matrix is important for a sort of complicated reason, so let's talk about how the analyzer measures and collects data. Internally, the MALDI forms a vacuum and an electromagnetic field. The laser strikes a target forming ionized particles. These particles are pulled in a line by the electromagnetic field into the detector without resistance or noise thanks to the vacuum. This area is called the flight tube. So what is the matrix's role here? It's kind of the magic ingredient because it's necessary for the laser to diffuse onto the target, generating the ionized particles. Without the matrix, the laser won't be able to make the right kind of reactions occur, leading to a failed identification. One more thing to touch on with the target is the BTS. You may know that as a Korean pop group, but this is different. We're talking about the Bacterial Test Standard. It's a control used to ensure the MALDI is operating properly, like how many other tests use controls to make sure they are operating properly. BTS is essentially a bacterial mixture of bits and bobs put together in a concoction so that the MALDI can read it and know if it is gathering data as it should be. Here we can see multiple BTS spots being tested along with the 3 test bacteria, and the spots are turning green. Here we can see, as the bacteria begin to fill in as full green dots, the first bacteria, my hand swab bacteria, turns red. And now, the rest of the bacteria after that start to fill in as full green bubbles. As the MALDI reads, it compares what it reads to what it knows. There is a large library of results of known bacteria that the MALDI compares tested organisms to. If there is a very strong resemblance, the score granted is higher, closer to 3. If the read is good, the spot will turn green to signify that. When the score is weaker, but still okay, the organism will be identified, but it will show up as a yellow dot. This is okay in some cases, but it's not great when you want to know what's going on and have an accurate identification. Sometimes when the read is not great, it has a lower score, the dot may turn red. This is more common with contaminating organisms and organisms not clinical in nature. Here we can see that the colony taken from my hand was not identified well, with a red mark in the circle. The score given was a low 1.18, which is unacceptable for an identification. But it can lead you in the right direction if you really want to identify with biochemical testing. In this case, differentiation between different Painibacillus species. But here we also see that the other organisms tested were identified with a higher confidence. The organisms used were stock QC organisms used in the microbiology laboratory, and we can see here they were identified properly. Now that we know how to use the MALDI, I'd like to reinforce how to apply organisms to the target plate, because at this step, we face the most crucial point in the process. If we fail to make this happen properly, the identification will fail. So I take the just right amount of bacteria, not too much and not too little, and apply it to the target. This way we have a layer that is not too thick or too thin, so that we may have a properly confident identification. And now as I apply the matrix, you can see I stabilize the pipette with my right finger. This is important just to make sure that the small drop lands on the target properly. Now we can watch as I apply the second QC bacteria to the target plate. I'd like to reinforce a couple of things about how to use the applicator stick. First, we want to grab a lone colony and only a small piece of it, not the full colony. And now we find the target we want to use and apply, using light to medium pressure, a full, thin, circular layer covering the whole target. And it's not recommended to knock over the biohazard bin like I did there. And now as I apply the matrix, I stabilize with my right hand to make sure the small drop lands directly on the target. So now that we know how to set up the MALDI and make all this magic happen, I'd like to talk more in depth about how the analyzer actually works. We're looking at a comparison graph that was shown earlier in the video. Each bar here represents an amount of ionic particles that struck the detector during testing. The larger the bar, the more particles of a certain mass hit the detector. So on the left is a generally large spike in lightweight particles. A few particles along the right get heavier and heavier, but as we move to the medium weight, we see a larger spike. And then to the right, the heavier particles seem to peter out, they're not so common. But how does the detector know the mass of these particles? The answer lies in how the flight tube and the laser are working on the organism's ionic particles. When the laser strikes and the particles are generated, they're all pulled by the electromagnetic field. And they're all pulled the same amount. So it stands to reason that the heavier particles with more inertia take longer to reach the detector, meaning the lightweight particles move fast, medium, kind of slow, and heavy, very slow. That way, the detector is able to discriminate between the masses of the particles. And what is with all of the colors on this graph? On the bottom we see the tested organism, which is highlighted in a solid blue. And the top we see one of the library organisms used by the MALDI. We can see three different colors, red, yellow, and green. Sounds familiar, doesn't it? The red particles don't match up too well with the blue particles on this graph. The yellow, kind of, and the green does. So we can see that good matches show up green like they do with the dots on testing. We can see that yellow matches up somewhat like they do on testing, and red doesn't match up like we would see on a bad matchup in testing. Thank you for watching, and with the knowledge you have from watching this video, I'm sure you'll be able to identify all of the bacteria